Hey guys, in this lesson, we're going to look at predicting using those exponential functions. So, those models that you hear about with the coronavirus and that kind of sort of stuff, a lot of that is based on exponential functions. So, let's take a look real quick. So, remember that our growth equation is going to be A equals C times 1 plus R raised to the T. So, remember that C is that final, that's basically what you're going to have as your answer. And then your C is your beginning amount, and then R is the rate at which it is increasing for this instance, and it's going to be a plus, remember, and then remember that rate you're going to write as a decimal instead of a percent. So it's going to be given to you as a percent, but you're going to have to write it as a decimal, and then raised to the T power. So this is kind of growing on what we did last time where we wrote the equation, or we just wrote the equation or picked the equation based on the scenario. So now we're going to take this and move a step forward. So let's take a look here. We have the first year of a charity concert event had an attendance of 5,250. The attendance increased by 3.5% each year. And then what was the attendance on the seventh year of the event? So let's take a quick look at what this is going to look like. So I know that my beginning amount, which is going to be C, is going to be 5250, and my R is going to be 0.035, and then T is going to be 7. And so my ending amount A is going to be 5250 times 1 plus 0.035 raised to the seventh power. So remember 3.5%, and I move the decimal over 2 places. That's what gives me 0.0325. I mean 0.035. So then I can go to my calculator, and I'm going to show you how to do that now. You're going to go to desmos.com/scientific. Okay, and it will have a scientific calculator for you. And so this would be a great tool for you to use. I know that we are using the graphing feature, and you could use it kind of as a scientific calculator, but this one does the job, I think, even better. So we'll take our example here. So we have 5250, and then I'm just going to use the parentheses, 1 plus 0.035, close parentheses, and then I'm going to use an exponent. So I'm going to hit Shift and 6, and that is what's going to do the exponent there, and I have a 7, and so you could see there, and I'm going to hit Enter, and it will pop up right here. And so I have 667946. So that 6 rounds the 4 up to 5, 5 rounds the 79 up to 80. So it'd be 6680. So using our rounding rules, we have that it was 6680. So you're going to round to the nearest whole number, whether it's up or down. So since that 4 rounds a 5 since a 6 rounds a 4 up to 5, then that rounds a whole 79 up to 80 there. And so 6,680. You can add the comma or not in your skill check. Doesn't matter here. So that would be the attendance after 7 years. So the next example, we have your family bought a piece of land in 1985 for $25,500. The value of the land has increased each year by 7%. What is the value of the land in 2010? So this is a little bit trickier because you're going to have to figure out what T is based on the number of years between 1985 and 2010. So my beginning amount was the purchase price, which was $25,500, and then the rate is 7%, which is going to be 0.07, and it's increasing. That's how I know it's going to be a plus. And then I'm going to have T is going to be 2010 minus 1985. So I'm going to find out how many years are in between there, and that's going to end up being 25. Okay, so after 25 years, what's that value of the land? Because what happens here is that you're going to take what the land was worth here, and you add 7%. And then whatever that value is, you're going to add 7% to that value, and then 7% to that value, and then 7% to that value. So it builds up, and that's why it's an exponential function. So then I would have A is equal to 25,500 times 1 plus 0.07, and then raise to the 25th power, and then plug that into your scientific calculator that I just showed you how to use, and then you will have your answer there. So we have an answer of 138,400, again rounding to the nearest whole number. So you can see that it grows really fast there because it's building on each other. So now let's talk about exponential decay. So this time it's going to be going down. So you're taking you have a full amount here, and then you're taking some of that, and then you're going to take some of that, and then you're going to take some of that, and then you take some of that. So it's going to come down each one. So let's look first. It says you bought $2,000 worth of stocks in 2001. The value of the stocks has been decreasing by 4.5% each year. And what's the value of the stocks in 2008? Again, you're going to have to figure out that time difference between 2001 and 2008. That's a little bit easier than the 1985 to 2010. So remember, I still have my ending amount. A is going to be the beginning amount, which was $2,000. You put $2,000 in. It's going to be 1 minus the rate. So this is C. Sorry, I did not write out what R was. C was 2,000. And then I have my R is going to be 0.045. So 0.045 is going to be R. And then raise it to the T power. So T is going to be the number of years, which between 2001 and 2008, you're going to have T is going to be equal to 7 here. So raise the 7th power. Okay, so C was equal to 2,000. That was our beginning amount. Sorry about that. I didn't write that in. I'm getting kind of rusty these days. So we'll plug this into our calculator, again, just like you see it, and then it will spit that out for you with what the value of the stocks would be in 2008. So we have the value is going to be 1,449. Add the comma or not, doesn't matter, still count it together there. So you can see that you've lost about a little over $500, $550-ish. So, just kind of helps you determine if you want to keep that stock or not. All right, so let's look at cars here. You guys are fixing to be old enough to buy your own car. So let's look here. You bought a car for $35,600. That's a lot. The value of the car decreases by 8% each year after you bought it. Now, you decided on a 5-year payment plan. So usually you just pay a car out. What would be the value of the car once you have it paid off? So let's look at how much it was originally. So our C, which is our original amount, is $35,600. And then it decreases by 8% each year. So my rate is going to be 0.08. So moving that decimal to the left 2 places. And then my time is going to be 5 years because it's going to be a 5-year payment plan. So once you have it paid off, let's see what the value of it would be at that point. So we have our ending amount is going to be $35,600 times 1 minus 0.08 raised to the 5th power. Again, plugging this into our calculator. So we have $23,463. So it's still a good rate, or still, a good value to your car there. But again, it's not worth what you bought it at originally for $35,000. So this is what you can use to predict future values. Base or attendance, sometimes talking about attendance of something based on exponential growth. And so just plugging this into those equations, you want to make sure that you're looking for, is it increasing or decreasing? So if it's increasing, you'll do plus R. If it's decreasing, you'll do minus R. And then you also want to look at the percent that it's increasing or decreasing, and make sure you write that rate as a decimal and don't leave it as a percent. All right, and that's it. That's all I have for you on predicting using exponential functions.